Hello and welcome to another Commodore 64 assembly programming video. This is the second video in this series. I hope you watched the first one because we'll be sort of continuing on from the first one and putting into practice a couple of things we learned from the first one. The first one is up in the top right hand corner if you haven't seen it. Okay. Right, so we left off where we were doing screen memory. Okay, so in our program we created some variables here which had either values or memory addresses, and we put them into variables which then get converted into the numbers during the assembly process, but it does make it a lot easier to see what you're actually doing. Okay, so before we sort of crack on with sprites, what I want to do is see these variables. I want to actually copy them off and put them in a file, a separate file, and the reason I do this is as follows. So if we look at constants, we have like screen mem, character in, character out, and CLS in there. So these are our variables. And I've made another one which I sort of cobbled together and stole a few bits as well online, called Vic2 constants. Okay, so here we have all the memory addresses of where everything is to do with the Vic2 controller. So the address for where the raster line is and the most significant byte for that, the border colour and screen colour, the sprite colours, the sprite pointers, sprite enable address, graphics pointer, basically pretty much everything you need for the Vic2 plus the colour codes here. And what I want to do is save for each different program, copying and pasting these. We are going to just import them in. So we only need to make these once and then we can just reuse them in any program. So here's our file for today's video. So the first thing I'm going to do is import source, first one, which is constants, ASN, and the second one, I think it's Vic2 constants. So I'll be able to use all the variables that are and addresses and numbers that are created in those two files. So let's begin our program. Okay, so what I'd like to do is I would like a sprite on the screen. I mean, we're not going to make it move and everything today. We'll save that for a future video, but I want to display a sprite on the screen. And while looking about, I came across this very handy tool, which is SpriteMate. Let's just zoom in on that a bit. This is a spritemate.com. I will put it in the video description, and this is a nice little sprite editor, and it does generate the code. Okay, so before we look into this, let's do a quick introduction on standard high-res sprites which use one colour and how they're put into memory. Okay, so how is high-res sprite data stored in the Commodore 64 memory? Okay, well, this is our sprite here. Okay, from here down to here, and it is 24 pixels along and 21 pixels down. Okay, and as it's a high-res sprite, it's single colour only, so each pixel is either on or off. Okay, so what I'm going to do, I'm going to just randomly click pixels to imagine drawing our sprite. So here is our sprite that I'm just doing here. It's just like a round round hollow ball. Okay, so let's just fill those in. We'll just fill them in dark green for now. Okay, so this is our sprite. Okay, so how do we store this in the Commodore? Okay, so the way we do that, if you'll see, I've divided the columns up, and each row is 3 columns of 8. Okay, so one there, one there, one there, one there. Okay, and what we actually do is we add this number for each section according to whether the pixel's on or off. So if we do this whole sprite here, this is 0, this is 0, and this is 0. So that's our first row. It's nice and easy. So what have we got here? So the first lot is 1. Okay, so the second row, the second section, so we've got 16 and 32, which is 48. So I've got to do some mental arithmetic here now. So 48 plus 64 is 112, then 128 on top of that, so it's 240. So it's only, it would only get to 255 if in each section every single pixel. I mean, I need to just check my arithmetic there. So it's 256 minus 255. Yeah, I think it's about right. It doesn't really matter. The principle's there. Okay, and this is 0 here. Okay, so we will just go down using the speed of magic and just fill all these out. And there we go. So forget this one here. If we, that wasn't meant to be filled in, but if we were doing this accurately, it goes like that. Okay, so, and this, okay, this here, which is 63 bytes, is how the sprite is stored. Obviously, if you're doing an assembler, you'd probably do it in a hex. So from the start of where the sprite 0 pointer is, you'd have 0, 0, 0, 1, 2, 42, obviously in hexadecimal binary format. And if you've ever done sprites in BASIC, you will know that you poke these into the address using data statements. So you'd see these all as data statements, data 0, 0, 0, 1, 2, 40, 0, all the way down. So that is how you put a high-res sprite into memory. Okay, so looking at that, that is how, if you in the old days, if you had some graph paper, you'd work out the codes for your sprites to use in BASIC or assembly. But this little tool here will take a lot of that pain away. So let's draw ourselves a sprite. Okay, so let's do our sprite in, we'll choose our colour, it's going to be black. Okay, let's do a nice face. Let's draw a nice even circle here. That's, you don't get more even than that, do they? Bit of a hairline there. Let's just do these. This bloke's got a really terrible face and some ears. Oh, I'm not going to fit many ears in. Okay, so let's do an eye. So another eye and a nice smile. That's, yeah, I mean, that's an artist at work here. So obviously this is a high-res sprite. It's only going to have one colour, and that colour is going to be black for now. We can change it as and when we want to, but for now we'll leave it as black. Okay, so we'll rename that. Well, we can just call it Sprite 0, can't we? Okay. Then what I'd like to do, you can save these. So you can save your working file here and then load it in again. In this case, I'm not really going to bother with that. I'm going to export this. So what I tend to do is we're using Kick Assembler I want it in kick assembler hex format. So I'm going to click hex there, and that saved me a nice little file. And here we have this, which we're not going to bother with. Okay, and this is our sprite data. So let's copy that, and we will put that. Let's zoom in here. Okay, we will put this. Maybe that's a little bit too much there. We will put this here. Okay, so that's where our sprite is going to start. So I want to put that onto the screen. So the first thing we need to do is work out where we want our program to start. This will be nice and easy. We're not going to use a soundtrack, so I'm going to put this in hex 1000, and then we're going to start our program here. Okay, first thing to do is put our basic start loader in. And we want the program to kick off from the start, which is there. Okay, so how do we get this onto the screen? Okay, well the first thing we need to do is point the Sprite 1 pointer address at the start of this, which is this label or this byte here. It's the same thing. Okay, so how do we do that? Right, okay, well I normally use hex here, but I'm going to use decimal just to show you. Okay, so each sprite uses 64 bytes, whether it's colour or whether it's multicolour, or I should say high-res or multicolour. Okay, and the sprite pointer, because it's an 8-bit value, will only point to however many blocks of 64 from memory location 0 the sprite is. Okay, so I want to put my first sprite at location at 200. So I'm going to load in to my accumulator. I will do it the decimal value 200, just for the purpose of the example. Okay, and I will store that value into the address, which is the address used for sprite pointer 0, which is an address in my constants. Okay, so I'm going to put the value, load the value 200 into the accumulator register, and it will store it in this memory location here. So load accumulator 200, store accumulator where sprite pointer 0 is. So where is my VIC2 going to look to render sprite pointer 0? Because it's not at memory address 200. It's blocks of 64. So let's get my calculator up. I'll do 200 multiply it by 64, and it's 12800. So this is where the start of my sprites is going to be. So sprites, I want them stored at 12800. So when the VIC2 wants to show sprite pointer 0, it multiplies this by 64 and it takes it straight to here, or here, where it starts. Okay, so that's the first thing. We've done our sprite pointer. And the reason we have a sprite pointer for 0 is because if we're animating, we might have the next frame of the animation straight after. Okay, and then the next one after that. So all we'd have to do is increase this by 1 and it will point to the next frame, increase it by another one, it will point it to the third frame, decrease it by 1, it will point to the second frame, and again point to the first frame. So that's how you do sprite animation, but we're going to be looking at that in another video. Right, so our sprite pointer 0 is done, so our VIC knows where the instructions for drawing a sprite are, which are here, so it knows where to do that for sprite 0. Okay, so the next thing is the colour for it. So we're going to load the accumulator with the value that corresponds to the colour black, which is defined in my Vic2 constants, and we're going to store it in Sprite Multicolour. It's 3 and 0. Okay, now the reason it's because it's an individual colour. Okay, because it's a high-res sprite. 2, 0 and 1, 0 are reserved for, or 1 and 2 are reserved for multicolour colours, which are shared amongst all the other sprites, which we'll go into in a bit. So I'm going to store the value for black in this address. So it's multicolour 3 or individual colour corresponding to sprite 0. Okay, I mean, I could make these a bit more self-explanatory by changing this constant name to indiv colour. But for now, we'll leave it as it is, as I've explained it. Right, so we've told it what colour we want. We've told it where the sprite definition lives at the moment. Now we want to do the positioning of the sprite. So let's put it in, and I'll use decimal again for this. So it's a value, not a memory address. We'll do 44. We'll load that into the accumulator, and we'll store that accumulator into Sprite 0, 0, X. So it's going to be 44 along, and we'll load 120 into the accumulator, store the accumulator into Sprite 0, Y. Which again is, these are both addresses that I've mapped out in here. Okay, but who wants to memorize all these? Not many people. Okay, so just to explain again, I can't just to store a number in a memory address, as in what the poke command is. You have to load it into the accumulator, either an absolute value like we've got here, or the contents of an existing memory address where you take that away and store it. So load accumulator, store accumulator is the same as poke. Okay, so what have we got so far? We've got our sprite address, we've got multicolour, we've got our X and Y position. Okay, so the last thing is we need to enable sprite 0. So I'm going to load the accumulator with a value. I'm going to put this in binary, just so you can see exactly how it works. So the sprite enable, this percentage sign means binary, is again, it's 1 byte, which is 8 bits. These are our 8 bits, 1, 2, 3, 4, 5, 6, 7, 8. And each one, starting from right to left, corresponds with a sprite number. So if the value is 0, the sprite is off. If the value is 1, the sprite is on. So I want to turn the sprite 1 on, so I'm going to load this binary number here, and I'm going to store the accumulator into the sprite enable address. Okay, so this is where we've got so far. We've defined our sprite code here. We've stored it in this address. We've pointed the sprite pointer in the Vic chip to that address using this method here. We've chosen the colour for our sprite. We've chosen the X and the Y, and we've turned it on. What else could we possibly need to do? Well, let's clear the screen and put some nice colours on. So if our sprite's black, then we need a nice colour to make it show. So let's load a nice blue colour. Store that in the what are they called in Vic2 constants? Border colour, screen colour. American format, and I want the same colour for the screen, so I don't have to reload it into the accumulator because it's already there. So I will store that in screen colour. I want to clear the screen, so I'm going to jump to subroutine to CLS, which is one of the built-in kernel routines that we discussed on video 1. And then once that's done, I want to return back to basic. So I'll use the return from subroutine there. Okay. Shall we see what happens when we run this, when we assemble it and run it? Let's do it. And there we have it. We have our lovely blue border, and we have a really photorealistic face. And that, my friends, is how you draw a single high-res sprite and put it on the screen. Okay, so the next thing we would like to do is a multicolour sprite. Okay, so what I will do, I will quickly explain how the multicolour sprite works. Okay, right, let's have a very quick look at how multicolour sprites are calculated. Okay, well, as you know, multicolour sprites is only half as many pixels along. So as you can see, this is how I would have a multicolour sprite, which is a sort of square and red square with green and blue in the middle. Now, if you notice down here, see the border of the square is 2 pixels along, because that counts as 1 pixel in the multicolour. That's why multicolour sprites do not look as detailed, because each pixel is 2 pixels along. And the reason that is so the sprite can use up 64 bytes of data in high-res and multicolour mode. Okay, so the way this is calculated for each pair, okay, so each pixel, which is, this looks like 2, this is 1 pixel, this is another one, this is another one, this is another one. Okay, so the way you calculate this, each pixel is, so for example, this is transparent, this will be 0, 0 for that pixel, 0, 0 for that pixel. For multicolour 1, which is one of the 2 multicolours that applies to all sprites, it's the same thing, right? It's 0, 1. For multicolour 2, it's 1, 1. And for the individual sprite colour, it's 1, 0. So you'd have to add this to all of these, and then you'd add them up along here exactly the same way as you did for the others. I can use the power of the internet magic to do this, but I don't really think I actually need to do that. It's hopefully self-explanatory enough. So anyway, back to the program. Okay, so what we're going to do, we're going to do a multicolour sprite. We're going to do it as a little trick, though, that some game developers do. We're going to have the multicolour sprite sort of being overlaid by this high-res sprite. So we have a multicolour filling and a high-res outline, which can make the sprite look like it's a high-res and multicolour, but in fact it isn't. So a little trick we can do on this program is, if I can duplicate this sprite here, okay, I will select that one, I will call it sprite 1. Okay, and I'll put layering on there and there. Okay, so what we can do is we can clear this sprite completely. Actually, let's do the rubber over everything. I didn't need to really duplicate it at all, did I? So as you can see the light grey there where this sprite is, you can see the overlay of the high-res black sprite. Okay. Yeah, I'm not really very good at this, am I? So we're gonna make his face multicoloured. Right. So we've got a nice clear sprite there. In here we toggle it from colour mode, and as you can see we've got a lot less, we've got half as many pixels across the top, and they're double the width. That is the downside of using multicolour. Right, so let's do this sprite's individual colour of yellow. Okay, and we'll fill in, oops, take it, put it into draw mode. We'll fill in around where his face is. In fact, I'm going to switch them round for a bit because I can't see the overlaying very well. That's better. Okay, so we've got the overlay as a guide here. And the good thing, because even though the pixels are twice as wide, because it will be underneath the high-res sprite, it doesn't really matter where the pixels overlay at all. See here? So let's do his whole face with a nice yellow colour. Okay, there we go, just there. So as well as the sprite's individual colour, which in this case is yellow, we've got two other multicolours which have to be shared across all the sprites, unfortunately, but you know, there is ways around it. So let's give him some cyan eyes. Okay, and we'll have a nice red smile and probably a red nose here as well. Okay, so we look in the preview window. That's what our high-res and low-res sprite overlaid together will look like. Here you can see what the multicolour one would look like on its own. See, a lot blockier than this one, and that's what the high-res one would look like on its own. Okay, so now we're done with that, we want to put that on our screen. So let's save this in assembly format. Let's kick assembler hex. We get a nice text file, and we've got sprite 1 is here. Sprite 0 is fine as it is. Okay, so back to our code. Okay, so under sprite 0 we will put sprite 1. Okay, so we can go through this pretty quickly. What I'll do for now is I'll put sprite 1 along a bit from sprite 0 so you can see the difference. So let's do the pointer first. So we've got 200 is sprite pointer 0. So the next block of 64 is 201. So we copy and paste. Can't really do that on a Commodore, can you? So sprite 1 is there. We want yellow as its individual colour because they're unique to each sprite. So we'll copy yellow and we'll put that in individual colour 1, and we will just move it along a bit. So we will load, let's do that to 150, store that in Sprite 1x. Okay, so, and we'll keep it at 120, so that's loaded in the accumulator. So we will store that in Sprite 0y and 1y. So they'll be the same distance down, but there'll be different horizontal points on the screen. This is our Sprite enable number. I did it in binary so you can see exactly how it works. And so we want to turn Sprite 2 on, so we will do that. Okay, so at the moment, what would happen if we ran this as it is? Well, let's have a look. Okay, so here's Sprite 0, which I'll outline, but yeah, there's something not quite right with Sprite 2. Look, and what do we know? It's because it's a multicolour sprite, and we haven't told the Commodore that it's a multicolour sprite. So, how are we going to do that? Okay, so first of all, the Sprite High-Res is very similar to the Sprite Enable. So in between defining where it is, okay, so we will do load the accumulator, and we want multicolour, which is for Sprite 1. Okay, so we'll do binary just so you can see. So we want 1, 2, 3, 4, 5, 6. That's Sprite 1. Sprite 0 is not multicolour, and we will store that in this address here, which is defining the constants. So basically what this is doing, all sprites are high-res except Sprite 1. So 0 is high-res, and we're going counting from 0 to 7 rather than from 1 to 8. So if we weren't, it'd be Sprite 2, but because of the way we're counting, 0 is high-res, 1 is multicolour, and all the rest are high-res. So the last thing we want to do is choose our multicolour colours. So I believe we had cyan for the first one, which is the eye colour, and we will store that into Sprite Multicolour 1. So it's multicolour colour number 1, so they're shared amongst all the sprites, these two colours. And the second one was red, and we will store that in Sprite 2. Okay, so any other multicolour sprites that I do will have their two extra colours as cyan and red, unless I change them. Okay, you can see that in some very bad games where the colours flicker on one sprite because of something, and they do on the other sprites as well. This is why. Okay, so let's have a look. Hopefully our sprite number 1 should be a multicolour sprite rather than a high-res. And there we go. Although there is something not quite right here. It looks like cyan is the individual colour. The red's fine. And yeah, I don't know what we've got there, what colour that is. So let's have a look and see where we've gone wrong here. I see exactly where I've gone wrong here. I've let autocomplete do this. This should be multicolour 1. I let autocomplete do that. So individual colour for Sprite 0 is black. Individual colour for Sprite 1 is yellow. The two multicolours are cyan and red. So that's one of the things you just got to be careful if your VS Code is doing autocomplete. That's better. Okay, so there's our sprite in the correct colours. Okay, but we haven't multi-laid them, have we? No, we haven't. And the whole reason for that is I wanted to show you the differences before I go on and do it. So let us just change, we'll get rid of this line. So when the accumulator is loaded with 44, it stores it in Sprite 0x and Sprite 1x without it changing to 150. So here we go. And there we have. So this is a multi-layered sprite with a multicolour filling and a high-res overlay. And that's how it's done, ladies and gentlemen. Right, before we finish, I'd just like to show you a couple of other things on sprites. If we look in the Vic2 constants, okay, if we look here, we've got Sprite double X and Sprite double Y. Okay, now I'll show you what this does quickly. Because we've got two sprites, we'll have to do it for 0 and 1. Okay, so just before we enable our sprite, let's pop it in here to make it easier. So I want to make my sprites double X, and it's the same. It's one register for, well, 1 byte of memory for all of them. So what I'm going to have to do, I'm going to have to make them both double X. So I will load in the binary value. So 0 and 1 are both double X. I will store the accumulator in Sprite double X. Okay, should we see what that does? There we go, and he's got a very squashed face there. So let's do double Y. Okay, because it's the same. I want it for 1 and 2. I don't need to change the accumulator value. I will just store the same value in double Y. Okay, let's run that one. And there we go. So slightly blockier, but there's our double height, double width, high-res overlay sprite. And yes, if you're wondering about why some games, particularly older ones, do look blocky, it's because they've used double height on the sprite and double width, or one or the other, depends. Okay, I think that is where we will leave this video. So I hope you all enjoyed it, and I will see you on the next one. Please leave your comments and questions on the YouTube comments, and I think the next video we will be looking at interrupts, which is very, very useful in assembly programming, and I'll go into that next time. So until then, bye bye for now.